have a pretty good head start on it. Again, set it up. Secant of the secant inverse of u is u by definition. So the secant of the secant inverse of u times the tangent of the secant inverse of u, because the derivative of secant of an angle is the secant of the angle times the tangent of the angle times the derivative of the angle, and that's equal to u prime. So to get the solution there, we set it up and get that. Now, what do I need to do as far as setting up the right triangle in this case? There's theta.
Well, it's secant again, so it'd be hypotenuse over adjacent.
That's 1 over cosine, yeah, which is hypotenuse over adjacent, yeah. So we get u over 1 right there, right? Okay, so opposite. So opposite squared plus 1 is equal to u squared, right? So the opposite squared is going to equal to u squared minus 1. So the opposite squared is going to be, the opposite is going to be the square root of u squared minus 1. Again, it's the positive square root because everything in the first quadrant is positive. So we're going to get u squared minus 1 here, the square root of that. All right. So, what do we need here? We need this is my triangle. What's the secant of this triangle? Or, it's just u, right? And if you think about it, what is the secant of the secant inverse of u? Well, by definition, the secant of the secant inverse of u is u. So u. All right, now, what is the tangent of that angle? Well, tangent's the ratio of what to what?
It's opposite over adjacent.
Opposite over adjacent, so what would be the tangent of this angle here?
Square root of u squared minus 1.
So we get u times the square root of u squared minus 1. So the derivative with respect to x of secant inverse of u is u prime over u square roots of u squared minus 1, and the opposite of that is the negative. Oh, that should have a negative with it right there. Sorry. Now, there's one little minor detail that's happening here that I need to add to it. I say it's a minor detail, but it needs to be done. When you get into this situation right here, when you take the inverse of trig functions, your first and second quadrant are where sine would be positive. So cosine inverse is negative in this quadrant. And secant would also be negative in this quadrant. Secant inverse would also be negative in this quadrant right here. Tangent inverse would be negative in this quadrant. So we would be talking about two different angles here. If we were talking about secant inverse being negative, we'd be in this quadrant. which would give us an angle here between pi over 2 and pi. Here we'd be between negative pi over 2 and 0. So in order to make sure that we're talking about the same angle, we have to give an absolute value with that u value. So, let's look at some derivatives with this. Let's say we want to know the derivative with respect to x of the sine inverse of x squared. Well, again, what that's saying is in the numerator, we need the derivative of u, which is u prime. What is the derivative of u here? 2x. All right, then it would be over the square root of 1 minus, and then what would u squared be? X to the fourth. What about the derivative with respect to x of, let's say, your cotangent inverse of, I don't know, let's go with x squared again.
Negative 2x.
You get negative 2x in the numerator. Be careful. Tangent and cotangent don't have the square root of it. So it's
1 plus x to the 4th.
just x to the fourth, yeah. X squared squared, right? Are we good with that? Okay, now, the last thing we're gonna look at here is the derivative. Let's go back. Let's do secant inverse, and I don't know. Let's this time make it 2x minus 1. So try that one on your own. And that is the end result. Any question about that?